Hi students, today we will discuss about inert pair effect. This will be useful to first year and second year students also. This inert pair effect appear in 13th, 14th, 15th, 16th group elements in periodic table. Let us take one group and I will explain from that. 13th group. What are the elements in 13th group? Boron, aluminum, gallium, indium, thallium. What is the atomic number of boron? 5. Configuration 1s2, 2s2, 2p1. This is the last cell. This is the first cell. This is the second cell. Here, second cell is the last cell. This is the valence cell. In this, how many electrons are there? Here 2 electrons, here 1. Total 3 electrons. So, valence electrons 3. So, it can exhibit maximum oxidation state plus 3. That means it forms the 3 bonds with 3 other atoms. Suppose if you take bond with chlorine atom, it will form BCl3 like compounds. Suppose if you take aluminum, it has also 3 valence electrons. 3s2 3p1 is the valence shell configuration. With these 3 electrons, aluminum forms 3 bonds. So AlCl3, it forms the AlCl3 like compounds. In this compound, what is the oxidation state of aluminum? Aluminum oxidation state is plus 3. That means these 3 electrons forms 3 bonds with 3 chlorine atoms. Like that, in this group, all the elements should exhibit the plus 3 oxidation state, because of all these elements has 3 electrons in their valence shell. Okay, but thallium exhibit only plus 1 oxidation state instead of plus 3. All these elements plus 3 oxidation state, but thallium exhibits plus 1 oxidation state instead of plus 3. Why? These 6s2 electrons not participating in bond formation. Only this single electron can participate in bond formation. So, suppose thallium combines with chlorine, then it will forms thallium chloride like this, thallium chloride, but not thallium trichloride. But if you observe aluminum and the boron, these elements, aluminum forms AlCl3, but thallium forms only TlCl, not TlCl3. Why? These 2 electrons not participating in bond. Why? Why means here from boron to thallium, moving from boron to thallium, atomic number from 5 to 81. Boron atomic number 5, it means this nucleus has 5 protons. Aluminum has 13 protons. Like that, thallium has 81 protons in the nucleus. So, number of protons are increasing from boron to thallium. These 81 protons has more attracting power on the electrons which are surrounded the nucleus. Like that, these 81 protons attract these 2 electrons also strongly. So that reason these 2 electrons not participate in bond. Because of that reason, these 2 electrons are called inert pair. These 2 pair. Inert means not participating in bond. That is the meaning of inert. Pair means 2. Inert means not participating in bond. So these two electrons not participating in bond formations. Because of that reason, thallium forms only thallium chloride, not thallium trichloride. Like this, okay, like this, if we take a carbon family, that means 14th group elements. 14th group elements. What are that elements? Carbon, silicon, germanium, tin, lead. Last element, lead. Carbon, atomic number 6, configuration 1s2, 2s2, 2p2. In valence shell, how many electrons are there? 4 electrons. So it can exhibit +4 oxidation state, maximum oxidation state +4. Okay, like that. Here 3s2, 3p2 valence shell configuration. Here 4s2, 4p2. Here 5s2, 5p2. Here 6s2, 6p2. Actually, it is also has to shows the +4 oxidation state. Should exhibit +4 oxidation state. But lead, this element name is lead, Pb, plumbum, lead. Lead exhibits only +2 oxidation state only instead of +4. Why? Same reason. These two electrons not participate in bond. So these two electrons are called inert pair. Because of that inert pair, lead shows only +2 oxidation state. These two electrons only participate in bond. So because of these two electrons, it exhibits +2 oxidation states. So if it combine with chlorine, it can form PbCl2, not PbCl4. Okay, like this. This is the inert pair effect. Inert pair effect. I think you understand this. What is inert pair effect? One more thing. If there is thallium chloride, suppose if it forms the TlCl3, although it forms TlCl3, but it is unstable. It transforms to, or it converts to TlCl. That means thallium here +3 oxidation state, here +1 oxidation state. So thallium from +3 to +1, it converts. So here what happened? +3, from +3 to +1, it converts. So it reduces itself reduced. Suppose oxidation state, if oxidation state increase, then that is oxidation. Suppose oxidation state decrease, that is reduction. So here from thallium +3 to thallium +1, so here reduction is happened. Itself it got reduction, that means it oxidizes the other elements. So thallium chloride act as strong oxidizing agent. Strong oxidizing agent. Thallium trichloride, because it is unstable, it converts easily from thallium +3 state to thallium +1 state. That means it is reducing itself. That means it oxidizes the other elements. So it acts as the strong oxidizing agent. Because of that inert pair effect. Bye.